Let's talk about frequency distribution. So frequency distribution is just one way that we can display our data. We don't want our data to just be a bunch of raw data. We want it in a way that we can actually look at it and interpret it. And so a frequency distribution will do that for us. Now, before we can build or construct our frequency distribution, there's a couple things that we need to calculate. We first need to find out how many classes we're going to have and our class width. A class is a group. So when you have a frequency distribution, you're going to group your data into classes. And we need to know how many classes and how big or how wide each class has to be before we can actually construct the frequency distribution. First, let's talk about the number of classes. So the way that we find this is using this equation here. 2 to the k power is greater than or equal to n, where k is your number of classes and n, little n, is your sample size. The best way to do this is just trial and error. You're just going to try a bunch of different number of classes, a bunch of different k's, until you find one that makes it greater than or equal to n. Now, class width. We take our maximum value from our data minus our minimum value of our data, our biggest and our smallest, and divide it by the k that we just found. That will tell you approximately how big each class needs to be. Now, we have some rules here for frequency distributions. Number one, each class must be equal width. We can't have one that's 0 to 5 and the next one be 6 to 500, because that's not going to truly show our data in the best way. So they all have to be equal sizes. They also must be mutually exclusive, which means they cannot overlap. So you can't have 0 to 5 and then 3 to 8. Right? Because 3, 4, and 5 would all fit into 2 different classes then. And we can't have that. They must be mutually exclusive. It also must include all of your data values. So every single observation, every single data point needs to be accounted for in your frequency distribution. You can't leave any out. You need to avoid empty classes. So the first class and the last class cannot have 0 observations in it. It cannot have a 0 frequency. Now, if you have an empty class somewhere in the middle, that's okay, because that's going to explain our data in a certain way. But we can't have ones at the lowest or the highest classes. And then finally, avoid open-ended classes when possible. So an example of an open-ended class, if we're working with ages, be 65 plus. So if possible, we want to have a start and an end to every single class in our frequency distribution.